So now, I'm using a 5.1 volt Zener diode, the LM358 op amp, as a current source. So we got the output coming to the inverting input 1000 ohm resistor. So 5.1 volts across the 1000 ohm resistor gives you 5.1 milliamps of current. We should be pretty spot on. And the power supply is accurate enough now where I don't need a multimeter. Now, if we use the red LED, now instead of the output providing 5.1 volts to put across the 1000 ohm resistor, it's providing 7.1. And again, these are kind of estimates. But in any case, that keeps 5.1 volts across that current setting resistor right there. Even though we changed the load from no load at all, just a short, to a red LED, which is a significant change. And here's still a fair change. Blue LED needs an extra volt, 3 volts. So now it's providing 8.1 volts approximately. Again, keeping that current at 5 milliamps. So now, here we have the LM358 op amp there, wired as a current source. 5.1 volt at the non-inverting input there because we used a Zener diode. So what that does is the output is going to provide whatever voltage is needed in order to set 5.1 volt at the inverting input right there. Of course, current doesn't go in or out of the input, it just goes to ground right there. 1000 ohm resistor, for each volt across it, you'll get 1 milliamp of current. 5.1 volts, you will get 5.1 milliamps of current. That's how it works. Now, between the output, which is what provides that voltage, usually you'll have a load. So first I did a jumper, there was no load, it was 5.1 volts. Then I had a red LED, it would have to provide 7.1 volts. Red LED will drop 2 volts, giving you 5.1 volts at the inverting input, and thus setting the current through that entire path to about 5.1 milliamps of current. So now, we're measuring the voltage at the output of the op amp, which is actually the voltage at the inverting input because there was no load. There was a jumper right there. And now we're going to attach, there's no negative feedback, so the voltage changed. So now we got a red LED. Basically, it's 2 volts higher. So it's not going to be a perfect 2 volts, but now we got about 7 volts instead of about 5 volts because we had to power the red LED as well in order to put about 5 volts across the 1000 ohm resistor that sets the current to about 5.1 milliamp. And now a blue LED. Again, we're going to need about 3 volts. It's not a perfect 3 volts, but there you can see we got about 8 volts instead of about 5 volts at the output because it's got to put 5 volts across the 1000 ohm resistor to set the current, but it also needs about 3 volts across the blue LED to get the current flowing. The current also flows through the blue LED. That's why it's lit up. And now, we're measuring the voltage across the 1000 ohm resistor, which goes from the inverting input to ground, because the non-inverting input, we have a Zener diode that's 5 volts. So with this short from the output to the inverting input, we expect about 5 volts right there. Now it's going to go to ground because the resistor is going to ground. I removed the jumper that goes from the output to the inverting input. We had a short. But there you can see I put the red LED in. Now current's flowing through the red LED. We already saw the output has to provide a couple volts to power the red LED. But in case it's holding 5 volts across that current setting resistor. 1000 ohm resistor. So we got 5 milliamps of current flowing through there. And now the blue LED, if I can get it plugged in there. Again, the blue LED needs about 3 volts. We saw the output had to provide 8 volts for this setup, but only 5 is across the current setting resistor. So again, we're maintaining 5 milliamps of current. Very straightforward.